Alright, well this is my senior, or my final design project for EMCH407. I chose to do a heat sink to show the heat removal that a heat sink does to electronic device, like something in a computer or such. Basically for this PowerPoint slide here, I have on the top left there is just a 2D SolidWorks drawing just to show the dimensions of my heatsink. All the units there are in millimeters. To the top right is a 3D model of the electronic device and with the heatsink on top. ANSYS was used for this project for get the simulation results for it. On the bottom left there is the temperature distribution. That red circle in the middle is the copper rod that is modeled to imitate the electronic device. And as you can see, the temperature dissipates throughout the device and exiting out through the fins, which is basically what a heatsink is made to do. And the bottom right is the heat flux that is shown through the device and out through the fins. From the results from ANSYS looking at the nodal solution, the picture on the bottom left there, the device maintains a temperature of around 300 degrees Kelvin, or I think it was 299 to be exact for this. The ambient air temperature used was 293, which is room temperature. This just shows that the heatsink is capable of keeping the temperature of the electronic device very low, close to the ambient temperature, and this will maintain proper function of the electronic device and it won't break down. I did hand calculations to just give another result of what heatsinks can do, and I got around 305 Kelvin doing different equations that I learned in heat transfer. Like I said in the result, the differences in the two temperatures from the hand calculations and from ANSYS, they're slight, about 5 degrees Kelvin. This is just due to different modeling done in ANSYS. Doing the whole and meshing, the ANSYS uses meshing to do finite element analysis, so this could alter the results slightly. Plus, ANSYS is a pretty confusing program to me, so I may or may not have modeled it completely correctly, but I got it close enough. And this just shows what heat sinks are capable of doing. Alright, I enjoyed the class, and you have a good summer.